All right, welcome back guys to the video notes. This is going to be our last video notes for this unit. We're getting into more proofs, and specifically we're using some more things that we talked about in geometry with complementary angles and supplementary angles here. And there are some extra properties that we're going to throw in here as well that are going to be very important as we work through different proofs throughout this year. So, label for today is going to be 3.5, complement and supplement proofs, and then date today is either the 16th or 17th, depending on when you have this class. Objective is I'm trying to solve proofs and work through them, specifically dealing with complementary angles and supplementary angles. And remember, we've talked about what those definitions mean. We'll talk about them a little bit more and kind of review those a little bit today, and then we'll have specific theorems that go with them. So with all that in mind, let's go to the first one here, just a little review. Like I said, we talked about this in Unit 1. So I want you to take a second, I want you to pause your video, I want you to sketch this diagram for me, and then we'll come back together here. All right, so hopefully you have this written down. Notice you don't have any points or anything like that you need to label. I just need to solve for x, or find the value of x here. So if I want to solve this, as a reminder, remember this little red box in the corner means that this is a 90-degree angle. So if we're kind of using what we did last time with angle addition, we could say one piece plus the other equals the whole thing. So in this case we have 3x plus 2 plus the other piece 8 plus 2x equals, in this case, the whole thing, which is 90. And remember, we call these complementary angles. Those are two or more angles that add up to 90 degrees. Don't need to fill out a proof for this one. I just want to do what we did in the past, which is just solving for x here. So once I have this set up, I can go ahead and start solving. I notice I have variables and numbers on the same side of the equation, so I can just combine those here. I have 3x and 2x, so I can combine those to get 5x. And then I have 2 and 8 here. Combine those to get positive 10. And then equals 90. We can continue. I have a positive 9 or positive 10, excuse me. I want to subtract that from 90. So when I do that from both sides, that will cancel out on the left. And on the right side, I have 90 minus 10, which is just 80. And then last step here, hopefully we understand, is just to divide by 5 on both sides. Cancel out. And we get x equals, and then 80 divided by 5. You could type this in your calculator if you don't know. But that is just going to be 16 here. All right, so just a little refresher, still kind of using angle addition like we did last time, but now we're kind of getting more involved with complementary angles and supplementary angles. And specifically, we want to try to do that with proofs. So we have a couple theorems that are going to help us as we're working through some of the different proofs with these kinds of angles here. So first definition I'm going to write down with me is the complement theorem. All right, and the complement theorem says this. It says if two adjacent angles form a 90-degree angle, or in other words, a right angle. If two adjacent angles, so remember adjacent meaning right next to each other, if those form a 90-degree angle, then they add up to 90 degrees. Okay, fair enough. Okay, simple enough. So if I want an example with this to kind of see what our statements would be like with this, if I want an example, here I'll move myself up here for now. We could say that if we had angle 1 and then angle 2 that's right next to it, if these form a 90-degree angle, in proofs we'd have to either be told that or we'd have to show that. But if we see that they form a 90-degree angle, then we could say measure of angle 1 plus measure of angle 2 equals 90. So this is very similar, or kind of, just re-hitting on things that we've already talked about, where we have two angles that add up to 90. Now I just have a specific name for the theorem. And it might not seem like it's that big of a deal just writing down the definition, but as we've seen from proofs, it's very important that we understand our math vocab that goes with all these kinds of problems here. Okay, so that is the complement theorem. And then supplement theorem is very similar. We can say this. We could say if two adjacent angles form, okay, and if we remember our term for this, we have two angles that are right next to each other on the same line. That's what we call a linear pair. So if they form what we call a linear pair, then they add up to And like I said, we've done this before. It's the supplement theorem. These are supplementary, which means they add up to 180 degrees. Okay? So another theorem that kind of helps us, and we can use this in our proofs if we had to show the setup of an equation, we could say if we saw a linear pair, which we've seen a lot of examples of this throughout the year, then we can say that they add up to 180. So we have a specific theorem that now helps us with that. All right, for example, if I were to draw this, remember if it's a linear pair, I just need to draw one line and then two angles on it. So let's just name these, for the sake of continuity, we'll say angle 3 and angle 4. And I would say if I gave you a diagram like this, if this was part of your given, then you could just say from this, measure of angle 3 plus measure of angle 4 equals 180 because of the supplement theorem. Okay, so something to keep in mind as we're trying to set up and practice setting up our equations and then being able to give the reasons is we now have the complement theorem and the supplement theorem that we can use if we're trying to show that. Okay, so with this in mind here, we'll scroll down. We'll go to example 1 here. So I want you to take a sec, I want you to pause your video, and I want you to just sketch this diagram for me real quickly. Should take like 10 seconds. And then don't worry about the given or the proof because we'll write that as we work through the problem. Okay? So should have it written down here. Again, just need to measure, or just need to label these angle 1 and 2, no letters or points to kind of deal with here. We're given that angle 1 is 12x plus 4, and then angle 2 is 7x plus 5. So if I were to work through this, one thing I would do to start, especially if this was on like a handout or a homework or something like that, is I would label what those angles are. So I would label this 12x plus 4, and then I would label this 7x plus 5. Okay, and that's just going to help me kind of visualize what those two angles would look like or where those go. So now I want to set up my proof. So same setup as always. And use statements and reasons here. Statements and reasons. Okay. If we're getting more confused on proofs, which we might have seen from that last homework or that last lesson, the good news is we can always start with the same thing. We can always start with our given. And then our statements that we're given here, we're told, like we said, angle 1 equals 12x plus 4, and then angle 2 is 7x plus 5. So I'm just going to copy that down. I want you to write this with me here. Equals 7x plus 5. All right, and just like before, I can't just go right into solving this problem because if I gave you this problem, hopefully you guys would be able to solve for x and then at the end prove or show what the measure of angle 2 was. But like I said last time, we need to show the setup of our equation just with the names of the angles. Okay, always do that first before you start jumping right into the actual problem itself. So if I were to show this here, if I see angle 1 and angle 2 and I see this diagram, well, hopefully we understand that this is what we call a linear pair, just like we talked about on that last theorem. So I'm going to say here, because of that, measure of angle 1 plus measure of angle 2 should equal what? Okay, if it's on the same line, hopefully we understand. That means they add up to 180. And what is my reason for that? How can I say that? Well, we have a theorem that told us if I see a linear pair like this, if it fits that description, then I can say that they add up to 180. So I'm going to say what we wrote down earlier, that is the supplement theorem. That is just the supplement theorem here. Showing the setup of our equation. Always need to do this step first. Now that I've shown the setup just with the names, now I can actually start to plug things in. So I'm told what the measure of angle 1 is. We wrote that in our given, so I'm going to plug that in. So that's 12x plus 4. And then we also do the same thing for angle 2. 7x plus 5 equals 180. And what is for my reason for that? Well, as a reminder, when I plug things in, anytime I plug things in this class, whether it's just a number or a whole expression, that's always just going to be substitution. Substitution is going to be my reason there. All right, so we have this. We're to this step now. And then, like we said last time, this is more like our algebra proof. So now I just need to solve like normal. So we can continue here. We see we have two x terms on the same side, and we have two numbers on the same side, so I can add those together. When I add 12x and 7x, that's going to give me 19x here. And then when I add 4 and 5, that'll give me 9. And this all equals 180 still. My reason for that, it's not the addition property, but since I added things on the same side of the equation, that's what we call combining like terms. So combine like terms. All right, and then we continue. hopefully we understand we should subtract 9 from both sides here. So when I do that, I get 19x by itself. And on the other side of the equation, 180 minus 9 is going to be 171. What is my reason for that? Well, we just subtracted something from both sides, so that's subtraction property of equality. Okay, give you a sec to get all that written down. We're just kind of continuing to go through the algebra problem. And then last step, we should know, divide by that number in front of x, which in this case is 19. You could just type this one into your calculator here, but when you type that in, you should get x equals 9 here. So x equals 9. Reason for that, since we divided, would be division property of equality. Okay, and on a lot of problems, we'd be done here. We found x equals 9, and we showed division property of equality. We showed all of our reasons, and we're good. But always need to double check, just kind of like we did it in the first unit here. In this case, I'm not trying to prove that x equals 9. I'm trying to prove that measure of angle 2 equals 68. So that's going to help me get to that point, but I always need to solve for x first. So now that I'm trying to prove what the measure of angle 2 is, well, if I look at our earlier given statement, we were told, or we said, that measure of angle 2 equals 7x plus 5. So what I'm going to do here is I'm going to go ahead and write that equation out, except now we know what x is. So I'm going to say measure of angle 2 equals, and then again it was 7x plus 5, so 7 times 9 plus 5. So I'm just plugging that in. So I'm just like we did in the problems, except now I'm just making a statement out of it. And then the reason, well, since we plugged something in, we talked about this before, that's the same as the other one. That is also substitution. Substitution here. And then last step, we just have to do the math. So measure of angle 2 is going to stay the same. And we want that in our statement just so I can match it up with what I was trying to prove. Measure of angle 2 equals 68 degrees. And if we do the math here, we could do 7 times 9, which is 63. And then plus 5 would, in fact, give us 68 here. So we know we got this right because we did all the work and it got the same answer as what we were trying to prove. And then reason, it's the same one that we used last time when we were in that lesson. We get to the end, if we just do the math, that's what we call simplifying. So anytime I'm just doing the math, I'm not adding things to both sides of the equation, I just multiply together and I just simplified the expression, so simplify. All right, and that would be my final proof for example 1. Okay, so same kind of idea. Once you get to the algebra piece, it's very similar, and you guys should be able to knock that out pretty quickly. It's just getting to that point. Can I show the setup with the names of the different angles or segments or whatever we're working with here? All right. That is complement and supplement proofs. Now there's other properties that I need to add in that are going to be very important as we go throughout the year. We'll use them at the end of this unit, and then we'll use them in every other unit and since, or continuing as we use proofs. So continuing here, some different properties that we're going to need to use or need to have down are going to be used here. So first one here, reflexive property of equality. I'll give you a sec to write that down. That is with an X, reflexive property of equality. And this one is fairly straightforward. We're just going to use, we'll just use letters for this, or we'll say these are angles. Okay, you can use this for angles, segments, numbers, whatever. But these are just general properties that we can use. So the reflexive property says this. It says, fairly straightforward, angle A equals angle A. Okay, that's all the reflexive property says. And it might seem obviously very straightforward, and why do we need a property for this? We will be using this kind of property later on, like I said, in this unit and in units to come as well. So reflexive property, all it says is some angle or some segment, whatever we're talking about, is always going to be equal to itself. Okay, fairly straightforward. Symmetric property, similar to this, but a little bit different. I'll give you a sec to write that down. The symmetric property of equality says this. It says, if, we'll put if here, if angle A equals angle B, then I can flip it around and say angle B equals angle A. So if A equals B, then B equals A. Symmetric property, what it allows us to do is it allows us to reorder things. So for example here, you guys can write this down, but you don't have to. On one of the proofs that we worked on in class last time, actually, we had an answer where we might have gotten to the end and we said 0 equals x. And technically what we were really trying to prove is we were trying to prove that x equals 0. Now we know that's the same thing, but we do need to add or start adding one more statement at the end where we reorder it. And we can say that's the same thing as just x equals 0. So that's all the symmetric property does. It doesn't, change values or anything like that. It just helps me reorder things if I need to take one side of the equation and flip it with the other. Okay, so that's the symmetric property. We'll use that sometimes. And then the last one, the biggest one that we will use a lot in this class on a lot of different proofs, is going to be the transitive property, what we call the transitive property. And the transitive property says this. It says if angle A equals angle B, so we're saying they have the same measure, and if angle B equals angle C, then what I can say is angle A equals angle C. So again, transitive property says if A equals B and B equals C, then A equals C. Okay, one way to think about this, if you're thinking of a real life example, is if I have two students, say we're in class, and I have two students who are the same age. Let's say they're the same age, they're both 16. So student A and student B are both 16, or they're both the same age. Let's say student B and student C also have the same age as well. So we add in a third person, they also have the same age as student B. Well, if A and B are the same age and B and C are the same age, then A and C would have to be the same age as well. Okay, that's all we're saying here. And we're going to use that whether we're talking about angles or segments in this class. And we'll just do an example right now to kind of show what that could look like in an actual proof. But keep that in mind, the transitive property. We'll use that a lot. All right, so last example for today, example 2. I do want you to take a sec, and I do want you to sketch these angles for me here, and then we'll come back together. But take a sec and just sketch these angles real quick. All right, so hopefully you should have those written down. It doesn't take too long to write those. So what we have in our proof here is we're given angle 1 and angle 3 are complementary, and then we're also given angle 2 and angle 3 are complementary. And we want to use that to say by the end here, measure of angle 2 equals the measure of angle 1. So if I want to set up my proof here or solve this, we know we're going to start the same, statements and reasons. And this proof is going to be a little bit different than the ones that we've done before. And here's the reason why. In the past, we've always had some equation that we're trying to set up. So I just have to show the setup of it, and then we know how to do the algebra from there. You're going to have sometimes, or some proofs like this in this class, where there's no algebra to kind of fall back on. You have to be able to show, using different theorems, that, for instance here, measure of angle 2 equals measure of angle 1. I don't need to be given any information about them in terms of what the actual angle measure is to show that. So that's what we're going to practice here. So first things first, even if it gets more confusing, I can always write in my given. So I'm writing in the given for my reason, and then the two things that I'm told are angle 1 and 3 are complementary, and then same thing with 2 and 3. So I'm going to say angle 1 and angle 3 are comp, and then angle 2 and angle 3 are complementary as well. So if you get to a proof like this, because we are going to work on a lot like this, and you don't have any algebra, or you're trying to set up an equation, you're asking the question, where do I start? How do I get through this proof? The question you need to ask yourself is always this: what do I know from my given information? Or in other words, what statement can I make because of my given information? So let's use that here. If I look at this and I say angle 1 and angle 3 are complementary, what do you know? What is information that you could tell me from that? Well, we know that means the definition of complementary means, or says, that they add up to 90. So that's my next statement, and that's what I'm going to say. Is I'm going to say measure of angle 1 plus measure of angle 3 equals 90, or 90 degrees. Okay, I looked at my given and I asked, what do I know? Well, I said if they're complementary, then that means they're 90. And what's my reason for that? I kind of just explained it there, but the reason for that is just going to be the definition of complementary angles. Okay, that is literally what the definition says. It says if they're complementary, then they add up to 90 degrees. If you put complement theorem here, that would work as well, but we use that in a little bit of a different sense. So this is just definition. Okay. What else can we say from that? Well, we also have that statement that we're going to put in the same box where we said angle 2 and angle 3 are also complementary. So what can I say? I can make a very similar statement. Since 2 and 3 are complementary, they also add up to 90 degrees. So if that is the case, if they're complementary, then they add up to 90. And I'm going to put that in the same box because it's the same reason. So that's that first question we're always asking ourselves. Do I know anything from my given information? Now we need to look here and use our statement and see, can we get to some place where by the end we're showing 2 and 1 have the same measure, because we do have to show that somehow. Well, if I look at the two statements I just made, I just said measure of angle 1 plus 3 equals 90 and measure of angle 2 plus 3 equals 90 here. So notice it's that property that we kind of just talked about earlier. We said if A equals B, so this would be B, and then B equals C, so I have this whole expression equals 90, and then 90 equals this whole expression as well, then A equals C, or in other words, these two expressions equal each other. Since they both equal 90, they equal each other. So what I can say next from that is I'm going to say measure of angle 1 plus measure of angle 3, that first expression, that would be A in this case, equals measure of angle 2 plus measure of angle 3, the other expression. And that would be C in this case, if we're using this property correctly. Okay, what is the reason for that? If two things are equal to the same thing, they're equal to each other. If two kids have the same age as someone else, then they have the same age as each other. So in this case, my reason is going to be that property that we talked about earlier, which is the transitive property. Okay, we'll talk about this more. It's a little bit more of a confusing kind of property, especially when I have algebraic expressions in there. It can be a lot to deal with, but just practice this for right now. This is going to be the transitive property of equality. Okay, so I have this here. We have measure of angle 1 plus measure of angle 3 equals measure of angle 2 plus measure of angle 3. And notice our end goal is to get here. This is where we're trying to get to. 2 and 1 are the same, is what we're trying to show. Okay, well, the problem is right now I have angle 3 on both sides of the equation. But if I gave you an equation like this, it's just like we would use our algebra skills. I can subtract the same thing from both sides. So if I subtracted or took away measure of angle 3 from both sides, on the left side they would cancel out, and I'd be left with measure of angle 1. On the right side, they would also cancel out and be left with measure of angle 2. And then the question would be, how did I get there? Where did the angle 3's go? I subtracted both of them. Okay, so my reasoning would be, like we've seen before, subtraction property of equality. Even though I'm not subtracting a specific number, I am subtracting something from both sides. And that's what that property said. And now we're almost done. We showed measure of angle 1 equals measure of angle 2. The only difference is we have to show the reverse of that. Measure of angle 2 equals measure of angle 1. So how would I go to my next step? Well, we know that's the same thing, 1 equals 2 or 2 equals 1. That's the same thing. So I can just reorder this and say measure of angle 2 equals the measure of angle 1. And then the reason for that, how do I know that? Well, we just talked about that property. I can just take the equation and flip it around. And that's what we call the symmetric property of equality. Okay, and this would be my final proof here. We'll work through all this. So like I said, you're going to see some proofs like this, not a ton right now, but later on you're going to see a lot of proofs like this where you don't just have an algebra equation that you're trying to show the setup of. And this is why proofs can be so difficult, because it's trying to figure out, how would I show this? How would I get through this proof? So my advice for any of these proofs is, number one, ask yourself that same question. Do I know anything from my given information? And then from there, how can I use my statements to kind of work through this and get to the end goal? Okay, it's going to take some practice and it's going to take some time. Don't stress out about it. Don't worry. I'll be here to help you guys out and get you guys better and better at this as we go throughout the year. Okay, so that is the notes for today. Rest of time you have is going to be to work on the 3.5 homework, and I will pass that out in class to you all. Same as always, if you guys have any questions on anything, feel free to let me know. Thanks, guys.